Okay, we're gonna do this quick, well, I shouldn't say quick, it's a combination circuit here. This is classic combination circuit. And we are gonna be solving for the total current in the circuit. So IT. So we're given our total voltage, 120 volts in this case. And we're given all the values of the resistors here in question 18. And I've filled them out here in another rendition of the circuit down below. And because we got all the resistor values, we're able to condense down the resistance into one resistor and find out our total resistance. So it's a bit of a tedious process, but I'll show you how we would go about that. So in this circuit here, whenever you're trying to condense down resistors, you're trying to first of all identify which of them are directly in series or directly in parallel. And in this question here, we have basically one option of a couple of resistors that we can condense right away. Two resistors that are directly in parallel. And these resistors here, R3 and R2, are directly in parallel because they are touching each other on either side. So because both sides of the resistor touch each other, that means they're directly in parallel with one another. So for example, the 35 ohm resistor is not directly in parallel with the 28 ohm resistor because, and if I just back up here a sec. Because this side indeed is touching the side of the 28 ohm resistor, but this side here is not directly touching the other side of the 28 ohm resistor. It has to go through that 8 ohm resistor first, which means they're not sharing the exact same voltage, which means they're not directly in parallel. And so we cannot condense those together. So the only resistors that are directly in parallel are these ones here. So we can go ahead and condense those using our rules when it comes to parallel circuits and resistors. So we can take our reciprocal of R1 plus the reciprocal, well, I guess in this case it's R2, plus the reciprocal of R3, which is going to equal the reciprocal of that total, which would give us our answer. Now, an easier way that I like to do that to solve the equivalent resistance of two resistors in parallel is, well, first of all, we want to remember that the total resistance is going to be less than the smaller of the two resistors. It's going to be less than 25 ohms because now we've created another path for the electrons to travel through. There's going to be less bumping in to each other of those electrons. It's going to have an easier path to flow. But the easiest way I like to do it when there's only two resistors in parallel is use the product sum method. So you can take the 25 ohms, multiply it by 35, and then take those two values and take the sum and then divide it. And you would end up with 14.6 ohms if you did that. And so, again, this is a tedious process because I think it's always important to just continue drawing out and condensing your circuit. And so you're going to have many different renditions of this particular circuit. So down below, I've drawn it out now with these two resistors here condensed into one resistor, that 14.6. All right, so now we come to the process of identifying what two resistors are in, or if there's any resistors, combination of one, two, or more, that are directly in parallel or directly in series. So in this case, there's none that are directly in parallel, but the 14.6 and the 8 ohm resistor are directly in series. And so we can condense those into one resistor. Now, it is also true they're in series because they share the same current. The same current has to go through each of those two resistors. And so we could actually say the same thing about this 10 ohm resistor and this 3 ohm resistor. You'll notice that the total line current has to go through the 10 ohm resistor and the total line current has to go through the 3 ohm resistor. But we won't worry about that. We'll save that one for later. The first thing we'll do is condense these two resistors into one. So finding out the equivalent resistance of two resistors in parallel is super easy. We're going to take 14.6, add the 8, and that's all you got to do to find the equivalent resistance. They just add up together. And so we get 22.6 ohms as our equivalent resistance. And now our resistors are becoming, this circuit's becoming a lot less convoluted. And it's becoming easier to identify what is happening. It's pretty obvious now that these two resistors are directly in parallel with one another, as both sides are touching and they must share the same voltage. And so we can go ahead and condense that using the product sum method or the reciprocal addition method. And we would end up with a circuit now, after combining those into one resistor, of 10 ohm resistor, 12.4 ohm resistor, and a 3 ohm resistor. Becoming even more obvious, these resistors here are all sharing the same path, and therefore the same amount of current has to go through them, meaning that they are in series. And so we can simply add those together, and we end up with 25.5 ohm resistors in the most simplified version of our circuit here. So that 25.5, now that we get it down to one resistor, represents our total resistance for the circuit. So if you were to put an ohm meter right there, one lead on that side, one lead on that side, after the circuit is disconnected from the source, of course, then that's going to read that 25.5 value. All right, so my total resistance is 25.5 ohms. My total voltage is 120 volts. Now I simply have to use Ohm's law in its most traditional form. I equals E over R. 120 over 25.5. And that is going to give me 4.71 amps. And that is the answer to this combination circuit question.